up until this point, we so far know how to pull out the GCF. That's the first type of factoring we learned. That's the first type of factoring you're supposed to always try. We also know how to factor standard form quadratics when the a value is 1, when you don't have a number in front of the x squared. It's simple. You just think what times what is a c value, the last number that if you combine together is a b value. And of course, make a list. It always helps. We also know how to factor perfect square binomials and trinomials by applying square roots. Those are the tools that we know so far. But I do want to go over a couple. Now, there's several practice problems here. I'm not going to go through all of them. If we had all the time in the world, heck yeah, I would love to go through each and every one of them with you so you could practice. Go ahead and pick one. Which one do you want to do?
A. 13.
Start with 1. Okay, so everybody, this is a standard form quadratic where the a value is 1. And it's pretty straightforward, pretty easy. Whenever your a value is 1, you could set this up. Why could you set that up when the a value is 1? Because x times x will give you that first term x squared. If you had a 6 right here, you wouldn't be able to do that because x times x is not 6x squared. Or if you had a 3 or a 4, it'd be a different story. You can't do this. But because the a value is 1, you could set this up. And then the thought process is, what times what is my c value? That if I combine together is my b value. And you know what? It's great to make a list. So let me make this list. I'm going to start with the number 1 or negative 1. I'm going to go negative 1 times 64. Negative 2 times 32. Negative 3, that's not going to work. Negative 4 times 16. Negative 5 is not going to work. Negative 6 is not going to work. Negative 7. Negative 8 times 8. And that's it. So I hope you guys noticed the process. Start with 1, 2, 3, 4, and just go through. If you're struggling with multiplication, get a calculator and divide 64 by 2. It'll give you the 32. 64 divided by 3, it'll be a decimal. 64 divided by 4, it'll be 16. Anyways, we have these 4 possibilities. Which pair of numbers combines together to give us a middle value b, negative 10? None. So what do we say?
No solution.
Not factorable. Now that is, for a no solution is when you can't solve an equation, when there is no answer to an equation. But this is not an equation, it's an expression. I am asking you to factor it. So you write not factorable. What does that mean? That you're not able to factor. That's it. So yeah, we couldn't do it. That's it. There's your answer, not factorable. I do think this one was important to cover because we haven't seen that many not factorable problems. Let's take a look at another one. Let's say, which one? 8. Okay, so 8, we cannot do this because the a value is 4, right? So don't even do that. What other tools do we have in our toolbox that we could solve this with? 2 perfect squares, right? So we could take the square root of this perfect square term, and we could take the square root of that perfect square term, and we could plug it into our factored form answer format. The square root of 4x squared is? Square root of 25 is? Okay, so we have both a 2x and a 5, a 2x and a 5. Now we got to decide with the signs. Okay, what signs belong right here? If you want to end up, like, you know, when you distribute, your last distribution is either a positive 5 times a positive 5, or actually, what it has to be positive and negative, positive and positive, negative and negative. I don't know. What do you guys think? Positive, negative, right? That's the only way you're going to end up with a negative 25 at the very end of your distribution. A positive 5 times a negative 5, that'll give you a negative 25. So this one, plus, minus, it works. We have factored it. Pretty simple, right? Yeah. And if you were to double check it, you'd see that it really does work, right? 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Positive 5 times 2x, that's a positive 10x. Positive 5 times negative 5 is negative 25. And you'll see that the middle terms really do cancel out because they're opposite. So you end up with the 4x squared minus 25 that you started with. Yay? So don't just think that because you have perfect square terms, you're going to be able to square root them. Like right here, the square root of 49x squared and the square root of 25, yeah, you could do the square root of those guys, which you'll get 7x and 5. And you'll get 7x and 5. But think about this. On your final part of your distribution, if you were checking it, 5 times 5, that'll be positive 25. So maybe they're both positive. Or maybe they're both negative, because a negative 5 times a negative 5 will also give us a positive 25. But we know that there's no middle term. We know that the middle terms are supposed to cancel out, and the only way they cancel out is if one's positive and one's negative. Does that make sense? So we know that it's not going to work, because if you want a positive 25, it's either going to be a positive 5 and a positive 5, or a negative 5 and a negative 5. But when you distribute, it doesn't work. Let me show you. 7 times 7 is 49, x squared. So far, so good. 7 times 5, that's 35x. But 5 times 7, x, is another 35x. It doesn't cancel. 5 times 5 is 25. So these guys end up being 70x's instead of canceling out. So this did not work. Does that make sense? So not factorable. Not factorable. NF, you could write it out, not factorable, whatever.
On the quiz, would it be NF or not factorable?
You could type in whatever you want, either not factorable or NF, yeah. Let's take a look at this guy. Here's another example that, I have a perfect square term here and a perfect square term over here. Maybe I could just square root them, plug them into my answer format. That would be a 3x, because the square root of 9x squared is 3x. And the square root of 1 is 1. And what signs do I put in here? If I put one positive and one negative, when I distribute, the middle terms will cancel out. I don't want the middle term to cancel out. So yeah, either both positive or both negative, so that this doesn't cancel out. What do you think? Both negative. And that makes total sense, because the middle term is negative, right? If you had both positive, then the whole thing would be positive. So yeah, both negative is the correct option. Now, a lot of us are going to be like, okay, I'm done. Let's move on to the next one. And it's going to be wrong. Because just because you could actually square root them, you're supposed to double check your answer. So let's actually double check. 3x times 3x, 9x squared. So far, so good. 3x times negative 1, negative 3x. Negative 1 times 3x is another negative 3x. Negative 1 times negative 1 is positive 1. What happens when I combine negative 3x and negative 3x? It's not going to equal negative 18x. So this did not work. This is not factorable also. Not factorable. Not factorable. You're not able to factor it. Cool? So right here you have a perfect square term and a perfect square term right there. It's really easy. What's your answer going to be? And this one will work because the middle terms are supposed to cancel out. That last number is supposed to be a negative 36. So what's your answer going to be? 2x and 6 plus and minus, or minus and plus, doesn't matter. Really easy, right? Okay. What about, let's do something fun. That one, 13. Crazy, huge, ugly. But I'll be honest with you, this is one of the easier problems. Because what's the only thing you could do on this? Greatest common factor. What would the greatest common factor be? And this might be a question on the test. What's the greatest common factor? Not only 4, but 4 and also some x's. But what's the maximum amount of x's you can pull out? 4. So 4x to the 4th is the GCF. Again, the number 4 came from the multiples like 12, 16, 8, 24. They're all divisible by 4, so I pull out the multiple of 4. And then you have x's in every single term. What's the maximum amount of x's you can pull out of all terms at the same exact time? X to the 4th. So that's how you get the GCF of x to the 4th. That might be a question on the test. Let's move on. What would be left on the inside if I actually pulled out a 4x to the 4th on the first term? In other words, 4 times what will get me back to this 12? 3x to the 5th. Now, why 3x to the 5th? Because when you multiply, the exponents need to be added to get to that, back to that exponent. How about the second term inside of the parentheses? Negative 4x to the 3rd. That's right. And how about the third term on the inside of the parentheses? In other words, 4x. Negative 2 with an x to the 2nd is right. And the last one in there? this times what gets us back to here? 6. So let's just put a plus 6. And that's it. Pretty easy, right? So we shouldn't get scared if we see something huge like that. But look at number 14. Uh-oh. Is there a GCF right there? No. So now I'm stuck. I need more tools in my factoring toolbox to be able to do this problem. So this is what I want to do. I'm going to cut this problem out. Now I'm just going to save it for later because I do need to teach you this method to be able to solve this type of polynomial. Let's go back to our notes from that blue page that I gave you. This blue page, well, mine's not blue, yours is blue. And we did already do the left column where I had the GCF, had factoring, standard form quadratic trinomials when the A value is 1. All you do is think what times what is C, that if you combine together is B. It had the perfect square trinomials, right? We did the left side. Let's look at the right side now and go to this method called factoring by grouping. Factoring by grouping. Okay, guys, so if you're falling asleep, wake up. This is the new stuff right here. Factoring by grouping. Now, what is factoring by grouping? Factoring by grouping is simply separating a polynomial into two groups. And then you simply factor something out of the first group, factor something out of the second group, then take a step back and factor something in common out of the whole thing, out of each group. And you know what? Let's zoom into this word common and let's write down binomial. Because on the 4-termed polynomials that I give you right now, we're going to be pulling out a common binomial, okay? So go to your notes, and I give you an example right here. It shows the polynomial x to the third plus x squared plus 1x plus 1. And if I ask you to factor, you can't pull out a GCF. There's no multiples in common. There's not even x's in common in all 4 terms. So this is where we have to follow the instructions. And step 1 right here says separate it into 2 groups. So all I do is rewrite the first 2 terms, leave some space, and then write the second 2 terms. Is everybody with me? Okay, and this is all done for you already. Maybe we could go right here to this blank spot and actually draw some parentheses, because this is what you need to do for the second step is factor something out of this first group. What's in common with the x to the third and the x squared? What could I pull out that's in common in both of these? There's x's, but how many x's could he pull out? 2 of them, right? So x squared. So I could technically pull out an x squared. And if I did pull out an x squared from both of these, what would be left in here? Oh, you could see the answer right there. What would be left in here? X plus 1, right? Let's do the same thing to the second group. What could I pull out of this second group? Now, the thing is, there is nothing in common in the second group. There's an x and a 1. What the heck? Nothing in common. But the instructions say factor something out of each group. I need to pull something out of here, even though I can't. So I'm going to pretend that I'm pulling something out. I'm going to pretend that I'm pulling out a 1. But that's kind of dumb because 1 doesn't change anything. But just for the sake of following instructions, I want to pull out a 1. Pull out a positive 1. Now, if I do pull out a positive 1 from the x and from the 1, it's going to be exactly the same. You guys with me? All right, so there's the x plus 1. So even though I worked it out, it's already done there for you. Okay, so now step 3, the last step. Factor out the common binomial from both groups. Exaggerated parentheses. So what I like to do is do this whole thing in some exaggerated parentheses. I'm going to put some exaggerated parentheses right here. Huge parentheses. And then I'm going to take the common binomial x plus 1, the common binomial x plus 1, and I'm going to pull it out right here to the front. I'm going to pull it out right here to the front. So here's my x plus 1 in the front of those exaggerated parentheses. And if I did pull out the x plus 1, the x squared would be left over, so that's what I would have left. And also the plus 1 would be left over, so I put the plus 1. So I purposely left this blank spot right there and that blank spot right there, so you could see that the x plus 1s were pulled out and now they're in the front, and now you have blank spots right here and here. Does that make sense? And that's your answer, but without the exaggerated parentheses with the spaces. That's your answer. X plus 1, x squared plus 1. There it is. Now, if you were to distribute, it will take you back to the original. X times x squared is x to the third. X times 1 is 1x. 1 times x squared is x squared. 1 times 1 is 1. Cool? Okay, so this is something new. Hopefully your brain is open like a sponge right now, absorbing this stuff. If it's not, open it up, right? Pay attention. Wake up. Let's go to that question that we stopped on just a couple of minutes ago. Let me paste it right here. I cut it. There it is, pasted. Let's use this new factoring by grouping method. All right, now you have the notes right in front of you. What is step 1? Two groups, and that's pretty simple. I mean, it's in the title. Factor by grouping, make two groups. So we're just going to simply write the first two terms, 18x squared minus 3x space plus 24x minus 4. And then what's the second step on factoring by grouping? Factor something out of each group. Okay, so let me go to the first group, put some parentheses right below, and let's pull out the GCF. What's the GCF? 3. And also an x, that's right. Yes, there's a multiple at 3 and 18, there's a multiple at 3 and 3, but there's also x's. So yeah, the GCF on the first two terms is 3x. What would be left on the inside? 6x minus 1. What about the second group? What could I pull out there? A 4. Okay, so pull out a 4. And that is a positive 4 that we're pulling out. So just for the sake of making it look nice, I'm going to put a plus in front of it. I know that's kind of weird. Normally just pull out a 4, you just write 4, but I'm going to put a plus in front of it, showing that it's a positive 4. What would be left on the inside? 4 times what will get you back to 24x? 6x. That's right, 6x. And 4 times what gets you to a negative 4, a minus 1 as well. And that's really good because we do have a common binomial here and there, and that leads us to step 3, which is factoring out that common binomial with some exaggerated parentheses. Okay, so check this out. I'm going to do some exaggerated parentheses. I'm going to recognize that my common binomial is the 6x minus 1, 6x minus 1. I'm going to write it out here in the front. I'm going to pull it out and write it down there in the front. Here it is. 6x minus 1. Dang, that's an ugly 6. I'm sorry. Let me change that. It's too ugly. There you go. 6x minus 1. That is the common binomial that we're pulling out. What's left on the inside of those exaggerated parentheses? 3x and the plus 4. And we're done. That's it. The only thing that you should do is write it with the correct size parentheses. 6x minus 1, 3x plus 4, and you are done. I know some of you are thinking, why the heck does he do this? Like, this is a waste of time. Kind of, yes, but I'll be honest with you. It's nice to be able to see that you pulled this out to the front and it's missing. It just makes it more visually appealing, especially if you're learning this for the first time. All right? Once you get the hang of it, you're not going to have to do blank spots with exaggerated parentheses. But right now, I want to really understand that you're pulling this out. It's no longer there, so I want to see these exaggerated parentheses at least on this first day that you're doing this. But there's your answer. Are we good? Yes. Back to our notes. You have it in blue. Mine's white. I don't know, do you guys want to try this one? Or do you guys want to do this one together and then try the next one on your own? Try it by yourselves. Okay, go for it. I want to pause it, give you guys some time, then I want to explain it. Step 1 is to separate it into two groups. So there's step 1. Step 2 is to factor something out of each group. So I want to go to the first one, and I want to, right below it, put some parentheses. Everybody should do that. And then you ask yourself, what is in common in both of these terms in the first group? X squared, right? There's a 3, but there's no number. There are x's. What's the maximum amount of x's I can pull out of both at the same time? X squared. So I am pulling out an x squared. What's going to be left on the inside? You got to think, x squared times what will get me back to the 3x to the third? That would be x squared times 3x would get me back to a 3x to the third. X squared times what will get me back to an x squared? That's just multiplying it by 1. It's already an x squared, right? So I need to put a plus 1 right there. So we factored an x squared out of the first group. Let's factor an something out of the second group. What could I pull out of the second group? A 5. If I pull out a 5, what's going to be left on the inside? The same exact thing, 3x plus 1. And we need these two binomials to be common. If for some reason you got a 3x plus 1 over here and a 3x minus 2 over here, then you'd be stuck and you would say not factorable. Okay? So yeah, we need these to be exactly the same. That way, we could take a step back, use some exaggerated parentheses, and actually pull out this 3x plus 1 and that 3x plus 1, pull it out and write it right here in front. 3x plus 1. And now what would be left over on the inside? You have the x squared. There it is. And this is a positive 5. There it is. There's my answer. I just need to write it with the correct size parentheses. Now, let's say you did this and you're like, man, I don't know if I did this right, but what if I did it wrong? You could always distribute 3x times x squared, that's 3x to the third. 3x times 5, that's 15x. Hey, there it is. 1 times x squared, that's x squared, there it is. 1 times 5 is 5, there it is. You're absolutely positively sure that you did it right. Okay? Let's try one more. Step 1 is to separate it into two groups. Now notice I don't write my first group over here. Like I always kind of like indent it, right? I start writing my first group in here. X to the 5th minus 2x to the 4th, space, positive 2x minus 4. I don't write it over here. I kind of indent it over here. That way I could have space, so when I do pull out my common binomial, I have space for it. On that first group, what could I pull out? X to the 4th power. Okay, what would be left over on the inside? X to the 4th times what will get me back to x to the 5th? Okay, and then minus just 2, right? Because I'm thinking x to the 4th times what will get me back to a negative 2x to the 4th? That'd be a minus 2, right? X to the 4th times minus 2 is negative 2x to the 4th. How about that second group? What could I pull out? 2, right? Bless you. And then what would be left over on the inside? X minus 2, and that's good because these are the same identical binomials. We need them to be in common, so we could actually pull them out. So again, exaggerated parentheses, pull out that common binomial, x minus 2. What's left over on the inside? There you go, x to the 4th plus 2. And there's your answer, x minus 2, x to the 4th plus 2. And if you're in doubt, you could always distribute to see if you actually get the original 4-term polynomial above. Okay? Do we get it?
Yes.
Great. Okay, it's time to move on to the fun stuff of the lesson.
Wait, we're still not done?
We're still, yeah, it gets more fun.
Supposed to be the fun.
Yeah, well, it's going to get more fun. Check it out, guys. Check it out. Factoring by grouping is essential. That's a tool that you need. Here's another tool. When you have a standard form quadratic trinomial, ax squared plus bx plus c, when the a value is not 1, you might have a 6, you might have a 5, and these are the steps for that. Okay? So pay attention. Very important stuff. Very, very important stuff. If I have a number out here, I'm going to have to use these 4 steps. So I'm not even going to read the steps to you. I want to ask you to read them to me. I have a number right here. I cannot set this up. I cannot do this. Why not? Because x times x is not 6x squared. So I cannot do that. So that's where I need these steps of factoring a quadratic trinomial when the a value is not 1. So what does step 1 say?
Multiply a times c.
Okay, so everybody do this. Put step 1, multiply a times c. And let's get a number. What is the answer going to be when I multiply my a value times my c value? Negative 18. Okay, so that's my answer for step 1.
Yeah.
I hope everybody understands that.
Just negative 18, or do we put that x?
No, just negative 18. That's your answer for step 1. And now, step 2, what does it say?
Think of the multiples of that answer that combine to give you
Multiples of that answer that combine to give b, which happens to be the negative 7x, right? Or just the negative 7 in front of the x. You guys with me? And it also says make a list, right? Tip, make a list. So let's make a list, but we're not making a list of this number. We're making a list of the multiples of the answer that we got to step 1. So let's do that. Negative 1 times 18. Negative 2 times 9. Negative 3 times 6. Negative 4 doesn't work. Negative 5. That's it. Those are the only possible ways of multiplying two numbers to get negative 18 besides changing signs. Which of these pair of numbers, when I combine them, gives me a negative 7? Second one? That's right. If we combine those, it'll give us a positive 7, and we want a negative 7. So we're going to change the signs to get that sign to change. Anyway, here's where it gets funky. Step 3.
Use that pair of numbers
to rewrite the value of b as two terms.
Use that pair of numbers, this pair of numbers right here, to rewrite the value of b as two terms, changing your 3-term quadratic to a 4-term quadratic. So we're going to rewrite the whole thing. It's going to read 6x squared. But instead of negative 7x, I want to write this guy right here. I want to write positive 2x minus 9x. And then the minus 3 at the very end.
What happened to that? Is it 18 just to get those two?
Yeah, it was just to get the step 1, negative 18, that was just to get these two numbers. And these two numbers are just to rewrite this middle term as these two numbers.
Okay, so we're always going to keep the C and the A.
And now, why would I want to change a 3-term quadratic to a 4-term quadratic?
Because now you can do factoring by
Because now you can do factoring by grouping. And that's your last step, which consists of another 3 steps in itself, right? So now you could do factoring by grouping. So now you could focus in on this. And again, when you do grouping, I would indent a little. In other words, leave some space. And you have the 6x squared plus 2x space minus 9x minus 3. You got your two groups right there. What could you pull out of the first group?
2x.
2 and an x. What would be left on the inside right there?
3x plus 1.
Right. That would be a 3x right there. And this would be a 1. And what could I pull out of the second group?
3.
A 3? Okay, now don't write this down, okay? If I pull out a 3, what would be left on the inside? Don't write this down. A negative 3x and a minus 1. Now, if you compare this binomial with that binomial, are they in common? No. They're exact opposites. Now, so what would have been better to pull out instead of a regular 3? A negative 3. So let me erase this. And instead of pulling out just a regular 3, I'm going to pull out a minus 3. That way, when I do pull out a minus 3 times what will get me back to a negative 9x? That'll be a positive 3x. Then you think negative 3 times what will get me back to a negative 3? That's just a positive 1 right there. And now you do have common binomial 3x plus 1, common binomial 3x plus 1. And now we're ready to do the exaggerated parentheses and pull out that common binomial of 3x plus 1.
So if we have a chance to change.
Good question. Absolutely. Always make sure that you have the same binomial, because if for some reason you end up with completely different binomials, then it would be not factorable. And just like in this case, we did pull out a negative, so it could be the exact same thing. That's what you want. You want a common binomial so you could pull it out. So we have a 2x left over right here and a minus 3 right there, and we're done. 2x minus 3, we're done. So our answer is 3x plus 1, 2x minus 3, ta-da. If you wanted to double check it, you could distribute, combine like terms, and it should give you that original quadratic trinomial. Shall we try number 2 together or on our own? Step number 1 is to multiply a times c, and we will get negative 36. So that's our answer for step 1. Step 2 is to make a list of the multiples of that answer. And I always recommend starting with the number 1 or negative 1. 36, negative 2 times 18. And if you're not too good at multiplication, you could just get your calculator and go 36 divided by 3. That'll give you 12. Negative 4 times 9. Negative 5. Negative 6 times 6. Now, out of this list, which combines together to give you the middle value b, which happens to be 5? And we don't have to change any signs, right? Negative 4 plus 9 is positive 5. That's exactly what we have right there. So here's where it gets a little weird. You're going to do step 3, which is changing your trinomial to a 4-term polynomial by replacing your middle term, 5x, with these new numbers from step 2, but put x's on them. So rewriting the whole thing, 12x squared, but instead of plus 5x, I want to put minus 4x plus 9x. I mean, if you were to combine those, you still end up with the 5x anyway. And don't forget about the minus 3 at the very end. So that was step 3, converting our trinomial to a 4-term polynomial. And now we could focus on this and do factoring by grouping. Step 1 on factoring by grouping, indent a little and separate it into 2 groups. 12x squared minus 4x space positive 9x minus 3. Put some parentheses under the first group, put some parentheses under the second group. What could you pull out of that first group? 4 and an x. What's left over on the inside? 3x with the minus 1. Yeah, you guys are right. And what could I pull out of the second group? A 3. And let's just work and see if we actually get the same binomial. 3 times what gets us 9x? 3x, right? So yeah, it looks good. And then 3 times what gets us a negative 3? Minus 1. So we do have a common binomial in the first group and the second group. Here's a common binomial. Let's use some exaggerated parentheses and pull out that common binomial out here. So we'll end up with 3x minus 1. And what's left over on the inside? 4x plus 3. There it is with the correct size parentheses. Of course, if you wanted to double check it, just distribute combine like terms and it should take you back to the original quadratic trinomial. Here's the last one. Now, think about this. If I just jump right in and say a times c, dang, 12 times 10, you got 120. That, I mean, no, you could do it, but it's like, it's really, you got to go 1 times 120, 2 times 60, 3 times 40. It's going to be huge, the list, right? So what's the first tool you're supposed to always try to use? GCF. So let's pull out that GCF of what? 2, right? If you pull out a 2, you'll be dealing with this quadratic trinomial, 6x squared minus 17x plus 5. And I don't know about you guys, I'd rather deal with this a times c, which is 30, as opposed to the original a times c.
Wait, I don't get it. Why couldn't this be our answer?
Well, this is factored, but it's not factored completely. You could continue factoring this right here, right? So when we look at this in here, the a value is still not 1, so we still have to do that multi-step process. Step 1 is to multiply a times c. In this case, it's 6 times 5, which is 30. And then step 2, you want to make a list of the multiples of 30. Start with the number 1, 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6. All right, so now step 3, well actually, which pair of numbers combines together to give us the middle value? And we're talking about the blue one, not the original. This guy right here, negative 17. Yep, that second pair of numbers, but change them both, the signs. That way we'll be able to get that negative 17. So now we could go on to step 3, which is rewriting the whole thing, but instead of the middle value being negative 17, we're going to replace it with negative 2x and negative 15x. And it's technically still inside the parentheses. Great question, right? And a lot of people, including myself, mess up on this a lot. So we're still working on the blue part inside the parentheses. So the blue part inside the parentheses, we're going to have the 6x squared. Instead of minus 17x, we're going to have a minus 2x minus 15x. And we will have the plus 5 at the very end. And this is, yes, still technically inside parentheses. But let's just factor by grouping right here. Step 1 is to rewrite it in 2 groups. The next step would be to factor something out of the first group. What could I pull out of there? A 2 and an x. What would be left over? 3x. Negative 1. Okay. And then the second group, what could I pull out of the second group? A negative 5. That's a good call. Negative 5. And what would be left over on the inside? 3x minus 1 as well. Okay, so now we have the exaggerated parentheses. We do have a common binomial right here. We could pull out that common binomial, giving us that common binomial out here in the front, 3x minus 1. And what would I have left on the inside? 2x minus 5. Now, wait, hold on a second. Yeah, let's not forget that is still inside the parentheses. So this is what I'm going to do. I'm going to rewrite this with the correct size parentheses, 3x minus 1, 2x minus 5. Let's not forget about this outside 2. Just going to put it right there. And that's your answer. Okay. If you wanted to double check it, you could distribute 2 times that, and then distribute this into that, and combine like terms, and you'll be good to go. Now, ladies and gentlemen, before we end, there is a shortcut.
Oh my god. Is it the diamond?
Oh my
Is it
gosh,
the-
listen to that.
Is it the
No,
diamond?
it's not.
It's not the diamond.
No, it's not. It's
Why
not.
not?
Okay, guys, so
I don't even want to know it now.
you know what?
Diamond?
For the sake of you guys not turning into an angry mob, I'm just going to not tell you the shortcut right now.
Yeah.
I'll show it to you next week when we get back.